Today we start section 1.1, chapter 1, section 1. These are our objectives for the day, okay? Number 1, plot points in the rectangular coordinate system. Number 2, graph equations in the rectangular coordinate system. Number 3, interpret information about a graphing utility's viewing rectangle or table. Number 4, use a graph to determine intercepts. And number 5, interpret information given by graphs. Any of that sound familiar at all? Good. That's a good thing. Because most of this stuff you've done since Algebra 1. I'm just going to go over it with you just to make sure that we're good. Okay? So let's start with plotting points in the rectangular coordinate system. Here's a rectangular coordinate system, yes? So if I ask you to plot the point, well, before we do that, let's just talk in generalities about the rectangular coordinate system, okay? Rectangular coordinate system is sometimes called the Cartesian plane, after René Descartes. Cartesian, yes? Okay? Usually assigned sections called called quadrants, yes? Which quadrant is this? That's the first quadrant. Why do we use Roman numerals to describe the quadrants? Yeah, because. Quadrant 2, quadrant 3, and quadrant 4. Okay? What's the pattern of signs in the coordinates? Quadrants. Why do we keep saying that? What kind of signs are in quadrant 1? Positive and then positive. What kind of signs are in quadrant 2? Negative and then positive, right? Because we got to go left and then up. What kind of signs are in quadrant 3? Negative, negative. And what kind of signs are in quadrant 4? Positive, negative. Okay. What is this called? It's the origin. And what are the coordinates of the origin? 0, 0. Okay. Which axis is the horizontal axis? X-axis. And which axis is the vertical axis? Y. God bless you. Are you okay? Okay. If I ask you to plot the point 2, negative 3, where would we go for that? Right 2, down 3. And that would be the point 2, negative 3, correct? How would I go about plotting the point negative 6, 4? From the origin, right? Left 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, up 4. Because when plotting points, which direction do we go first? Left or right, and then up or down. Have I said anything that you have never heard of before? Good. Okay? Okay so far? What if I asked you to graph the line y equals 2x? Could you graph that line? How would you graph that line? Why would you start at the origin? There's no y-intercept, so we would start at the origin. From the y-origin. From the origin, where would we go? So 2 over 1, the slope is 2 over 1. So from the origin, I'd rise 2, run 1, rise 2, run 1, and so on. How many points does it actually take to make a line? 2. How many am I drawing? Yeah, all of them that I can see, right? Because then I can see the line very clearly. If it's just 2, that's sometimes hard to see, right? And then it's a lot easier to sketch in my line like that. Does that make sense? How much transformation stuff do you remember? I'm so proud of you. Y equals x plus 2 squared minus 1. How would we go about graphing that? First of all, what shape is it? A what? A parabola, right? Parabola. So where would I go first? I'm starting at the origin. So does it matter which way I go first? Not here, right? Typically we go from left to right, so typically go left 2 and then down 1, but it doesn't matter if we go down 1 and then left 2, we get to the same place. And what is that? That's the vertex. Good. From the vertex, is there a multiplier in the front? No, so that we know this is parent function shape, which means I can go 1, 1 from the vertex, 2, 4, because 2 squared is 4, and then 3 from the vertex, up 9, because 3 squared is 9. I also know parabolas are symmetric, so I can draw in my parabola without too much trouble, right? Any questions about that? So far, we've actually covered 2 objectives, plotting points and then graphing equations. Do you feel confident with this? Okay. Would you turn on your calculator? Look, I already pressed the on button. Would you please come on? Thank you. Does yours always take as long to come on as mine, or only when I'm trying to show people something? Only? Okay. Awesome. Yours is probably already on, isn't it? Sometimes my calculator's a jerk, but I don't want to say that out loud because I don't want it to hear me. Yeah, probably. Sometimes it is, though. But to be fair, sometimes I am. Oh my gosh, can you please come on a little faster? Please, calculator. So if I start a new document that's a graph, oh please. No, I don't want to save the old one. I want to start a calculator that's a graph. And I want to look at my window. How do I do that? Let me see if I can make it where you can see it. Oh, you're going to be a jerk again? Awesome. That's so cool. I love it when you do that. That's a little better, yes. No, I don't think it has anything to do with that. I think it just likes being a jerk. Because see, now it's fine. Okay? So we need to go look at the window. So number 4. And we want to look at the window settings. Okay? Now, do you know what all of these things mean? X-min, what does that mean? The lowest number on the x-axis. Okay? What does x-max mean? Highest number on the x-axis. And x-scale? How is it counting? Right now it's counting autos, so it's probably going to count by ones. But we could tell it to count by ones. We could tell it to count by 2s. We could tell it to count by 10s. Like every hash mark on the graph would be worth 10 if we told it x scale was 10. Does that make sense? Okay. Y-min, lowest on the Y. Y-max, the highest on the y-axis. And Y-scale. You got that one? How is it counting along the y-axis? Can we make these 2 different numbers? The x-scale and the y-scale? Yeah, for sure. Okay. So here's what I need you to understand. The computer uses the TI-84 as an example. But guess what's the same? It just looks different. But all the things mean the same thing. Okay? And a lot of times when they're doing it on the computer, they'll say that the window looks like this. They'll say 2, 10, 1 for x's, and for y's, it'll be -5, 5, 5. So what does that mean? X min, X max, X scale. Y min, Y max, Y scale. Does that make sense? Yes? Okay, it's not too hard to adapt to. Okay? Use a graph to determine intercepts. Let's look at the two things we just graphed. The pink line, which was our line, y equals 2x. What's our x-intercept? 0, 0. And what's our y-intercept? So basically, can you look at a graph and find the intercept? Hopefully so, right? Look at the purple one, which is our parabola. What's the x-intercept? Oh, there's 2, isn't there? -1, 0 and -3, 0. And where's our y-intercept? 0, 3. Any questions about that? Okay. Interpret information given by graphs. Can you look at a graph and tell me the rate of change of the pink function? Maybe it was time and distance. Could you tell me the rate of change of that function? Because we know rate of change is slope, right? It's slope, okay? So you could look at that easily and tell that that was 2. Or if they had a different scale here, you could figure that out as well, yes? Okay, do you have any questions about that? That's literally every objective we have for section 1.1. You good? What could you always do if you're not good? Ask, for sure. Okay.